Next lesson is on polygons. So a polygon is a closed plane figure formed by 3 or more line segments. A circle is not a polygon because it's not made up of line segments. It's curved, so no curves. A regular polygon is a polygon whose sides are all equal and whose angles are all equal. Next we have the definitions for what I call the family tree. So at the very top we have quadrilateral, which is any four-sided shape. Now, depending on some characteristics, quadrilateral might be something else as well. It could be a trapezoid, which means it has one set of opposite parallel sides. And it could be a parallelogram, which means it has 2 sets of opposite parallel sides. Parallelogram can get stronger still. It could be a rectangle, where all 4 angles are 90 degrees. It could be a rhombus, where all 4 sides are the same. Or those 2 things could happen at the same time, and that's a square. A square has 4 right angles and 4 sides that are the same. The square is the regular quadrilateral, and 4-sided shapes are the only ones that have this kind of weird thing going on where there are a bunch of different names for different variations. There's a theorem here that says the polygon angle sum theorem. Says take the number of sides n, subtract 2, and multiply by 180. The reason we do this is if we take the number of sides and subtract 2, we'll have the number of triangles we can cut the shape into from one vertex. So on a triangle, you can't cut it up at all. And triangles are 180 degrees. A quadrilateral, you can cut once into 2 triangles. 2 triangles would be 360 degrees, 2 times 180. A pentagon, a 5-sided shape, if you start at one vertex, you can cut twice. That's 3 triangles. 5 sides minus the 2 cuts is 3 triangles. 3 times 180 in each triangle gets us the 140. So the only thing we have to do here is fill in this table, and then I can turn you loose to an assignment. So I think we all know that a triangle has 3 sides, quadrilateral has 4, pentagon has 5, hexagon has 6, heptagon has 7, an octagon has 8, and an n-gon has n. This bottom row is going to be formulas. The sum of the angles, well, we already know these ones from above. So it's 180, it's 360, it's 540. For the hexagon, we would do 6 minus 2 times 180, and that is 720 degrees. For a heptagon, we would do 7 minus 2 times 180. That is 900 degrees. And for an octagon, we would do 8 minus 2 times 180, which is 1080 degrees. For an unknown polygon of n sides, it's just n minus 2 times 180. Now, if it's a regular polygon, what we're saying is all 3 angles are the same. The way we do this to figure out what it is we take the sum of the angles and divide by the number of sides. So in a triangle, one interior angle would be 60 degrees if it's regular. In a quadrilateral, we will take the 360 and divide that by 4 to get 90 degrees. In a pentagon, we would take the 540 and divide that by 5. And I'm going to start using my calculator for this to make sure I get them right. That is 108 degrees. For the hexagon, we'll take our 720 and divide it by 6. That's 120 degrees. For the heptagon, we'll take the 900 and divide by 7. This isn't going to be pretty. We'll round it to 1 decimal place. So this will be 128.6 degrees. It's 128.57. 7 tells me to round the 5 up. For an octagon, we will do 1080 divided by 8. And I believe this one works much nicer. Yes, this is 135 degrees. And for a random n-gon, it would be n minus 2 times 180, all divided by n.